All right. Hey, welcome back, guys. I hope you are ready for another amazing Algebra 2 note video. All right, we are in section 5 today and still in chapter 6. All right, we are about halfway through chapter 6. And so we're talking about real roots of polynomial equations. We've been working a lot with polynomials. They're not going away anytime soon. So let's jump into it. Okay, so basically what we're looking at here is we have, let's see, we'll get the pointer up there. All right, so we're still going to be dealing with factoring. Okay, you can see that right there. The first example problem, we're going to do some more stuff with factoring. As it says, it could be a trinomial, but the example problem that we're going to be doing is a factor by grouping. Okay, so that's what we're dealing with here. Don't forget how to use synthetic division, because that is also something that we're going to be doing. And then there is this big chunk right in here that I just took. Okay, so that right there, I've highlighted the important parts. So when you are writing down these notes, as you should be, you just need to write down the important parts as long as that makes sense to you. If it doesn't, then you need to write it all down. Okay, you will have to do the graph, anything that I've highlighted, right? All that stuff, all that. You're going to have to write that down. That's minimum of what you have to write down. Okay, read through the whole thing, but minimum, write down at least what I have highlighted there. Okay, now you can use the graphing calculator right here to determine multiplicity. So there's some problems that we're going to be doing in class together that are from these notes. So you still have to write the problems down. And then during class, just remind me to do those problems, because we will be really wanting to understand how to do that. It's going to save you a lot of time if you can do that with the graphing calculator. Okay, and as this says right here, that's examples 2 and 3. Show you guys those in class. Okay, so I'm just going to scroll it right back up to the top. Just make sure that you have all the necessary notes down. You can pause the video, do all that stuff. But let's jump into the example problems. Okay, so first one right here, this is going to be a factoring problem. And step 1 is you're actually going to want to take this negative 50 and bring it over to the left-hand side there. Let's rewrite it so you can see everything all on the same side. And that's now going to be a positive 50, okay? Now we have 4 terms. So we're looking at a 4-term polynomial, which means factor by grouping. Okay, so what I'm going to do, let's just take these first 2 terms, keep them together. This will work. And then keep these last 2 terms together. And then that should work also. All right, so here's what I notice is that in the first set, these guys are both sharing something with the variables and the exponents. They're both sharing an x squared. So what I want to do is factor out an x squared. So right over here, take out the x squared and then rewrite what they have left, which in this case is simply going to be x minus 2. Okay. Now, in the second set of parentheses here, you'll notice that they're both going to share a 25, and you're going to want to factor out a negative 25. Here's why. Because of this negative sign here. If you factor out a positive 25, you're not going to leave yourself with a negative in the parentheses. And remember how to double check if you have factored by grouping correctly is that the set of parentheses will be identical. And you'll see that work out right now. So let's factor out a negative 25. Okay, so this one right over here. And then what is left over in the parentheses, if you factor out a negative 25, is going to be just that, something identical. Notice x minus 2, x minus 2. So we've done it correctly. And if you didn't factor out the positive, scratch that. If you did factor out a positive 25, it wouldn't match. So you got to factor out the negative 25. Okay, now next step is to pair these two together. What you factored out will now become their own set of parentheses, x squared minus 25. And because you have correctly factored it, the second one can be crossed out. And then you're going to have the x minus 2 because they're the same identical binomial. So we just need the single binomial. Now we're not done yet because in the directions it says solve. So we need to solve each one of these sets of parentheses. What you'll notice though is that this set of parentheses right here, x squared minus 25, that is a perfect square binomial. All right, how do we know that this is a perfect square binomial? Because the first term, x squared, that is a perfect square. The second term, 25, that is a perfect square. And the third piece to this little puzzle is that it must be subtraction. So all three pieces are there. So we know this is a perfect square binomial. So it's going to factor down into two sets, x minus 5, x plus 5, and the x minus 2 stays. All right, so that doesn't change at all. Now our final thing here is just solve each set of parentheses. So this is what we're going to be left with. We're going to have a positive 5, a negative 5, and a positive 2. When we solve all three sets of parentheses, that's what it works out to be. Okay, perfect. There we go. So that's number 1. Now number 2 and 3, you can see here, you're going to state the multiplicity, but we're going to do these in class. So bring the calculator. I'm going to show you how to graph these full polynomials on the graphing calculator. And while looking at the graphing calculator, we can determine what the multiplicity of each root is. So come prepared. If you don't have your calculator, you're going to miss it. That's not good. Now, the final example problem, I've actually already worked out, and I'm going to guide you through it because there was a lot of steps here. So it's kind of like I'm giving you the roadmap already, and I'm just guiding you through to get to the end of this little miniature journey of a problem, okay? Because it's pretty big. So you're going to want to copy all of this down, okay? I mean all of it to understand every little step. And I gave you every little step. All right, so this is one of those things where I'm showing you everything in it so that you can understand why did he do this. I even tagged on notes to it. So every little thing that I have here, copy it down. All right, so the given problem is right there in black. Identify all of the real roots. Here's the polynomial, 2x cubed minus 3x squared minus 10x minus 4 equals 0. So we don't have to move anything around. Now, you can see rational root theorem right there because we're going to use the rational root theorem. And then everything written in red, and then, I mean, you can see this little part right here in blue, but all of that is going to be dealing with the rational root theorem. So here's what we do. The first coefficient, even backing up one more step, make sure it's written in standard form, which means biggest exponent up front, and then we decrease as we go down. So the first coefficient, which is with the biggest exponent, is going to be your Q value in the rational root theorem. And then the final term over here, whatever that may be, is going to be the P value in the rational root theorem. And here, right there, this is the little equation for the rational root theorem. But it's not quite as simple as just saying, oh, you just take a negative 4 and divide it by 2. Unfortunately, it's not that simple. So the theorem says what you have to do is take the value of P, which if we go back up here, remember that was the negative 4. In this case, you could just think of it as it's 4. And you have to list out every single root of the number 4. Or another way to think of it is every factor right here, every factor of that term. So the factors of 4 are 1 and 2 and 4. And you'll notice we also have to put plus minus with every single one of these because you don't know which one is getting used, so you have to put both options. And then Q, which is in the denominator, What are every factor of 2? It's simply plus or minus 1 and plus or minus 2. Then comes another fun part where you must figure out the answer of every single one of these division problems. What is 1 divided by 1? It's 1. What is 1 divided by 2? It's 1/2. What is 2 divided by 1? It's 2. Remember, 2 divided by 2, that's still 1. And then we have 4 divided by 1 is 4. And then 4 divided by 2 is 2. So everything is represented right here once it's been solved. Now that you have every possible root, because remember this is the root theorem, then we move down to this note right here. Graph the original equation in the graphing calculator, and you want to, as it says, see which roots actually connect with those, meaning these, from the rational root theorem. So when you graph this on your graphing calculator, you're going to want to look for where the graph crosses the x-axis, and it will be one of these numbers. It's not going to be all of these numbers. So the rational root theorem tells us one of these does work. Now you need to determine which one it actually is. It could be more than one, but it will not be all of them. Okay, so we graph it on the graphing calculator, and it will determine that it actually is -1/2, which means we're connecting with this number in the rational root theorem. That's the only place that the original graph here and the rational root theorem match up perfectly. So once we know that, it's -1/2 right there. That's why I put the little blue check mark. What do we do with the -1/2? We use synthetic division. Use synthetic division. So this right here is our divisor. We're dividing into the original polynomial. Synthetic division we've done through a couple different sections in this chapter. So right here, I'm using synthetic division. Okay? Do that. What is it going to give you? It's going to give you your brand new trinomial right here. Okay? This trinomial right here is this guy. Now we have a trinomial, and we are still breaking things down one step at a time. Now what did I do? I took this trinomial, and I started to simplify it. Because every term shares a 2, I factored out a 2 from 2 and 4 and 8, and this is the new trinomial that was left over. Once you have this final trinomial, then you just solve for x. Now, I'm telling you in advance, it doesn't factor this specific one, so I had to use the quadratic formula. So this right here is me setting up the quadratic formula, and these are all the steps in simplifying the quadratic formula into my actual solutions. Now you'll notice -1/2 is there. We determined that that really was an actual root. The graph proved that, but the graph did not prove this one right here. There was another root. That was the whole purpose of all of this, to identify all of the real roots. The graph didn't properly show that because the rational root theorem did not come up with it. So it does exist, but we have to determine exactly what it is, and that's why we did all of this work here to get down to the final 2, in that case actually 3 roots, because we have 1 here and then the plus or minus. Okay? All right, guys, that's what I got for you. That covers all of the notes there for section 5, chapter 6. We will see you in the next one.